Greeting and welcome to the fourth and final day of Marubeni Citizen-Cincom's Tech Days, an alternative to IMTS. My name is Glenn Cruz. I'm the Western Regional Sales Manager for Marubeni Citizen, located in the Fountain Valley, California office. In addition to direct sales and support, the 14-member staff of the Fountain Valley office serve and supports 3 dealers and their 4 offices located throughout the Western United States. We're proud to host today's event, where we'll demonstrate 3 models of Citizen machines for you, the M32, the L32, and the B&J 51SY6. But before we begin, our Executive Vice President, Brian Such, has a special message for you. Let's hear from Brian.
Welcome to MCC Tech Days 2020. I'm Brian Such, Executive Vice President of Marubeni Citizen-Cincom. And on behalf of the entire MCC team and our national distributor network, I would like to thank you for joining us today. As we changed plans after IMTS was canceled, we knew we needed to create our own alternative to IMTS. Our outcome is to offer 4 days of live demos streaming from all 4 MCC offices, demoing Cincom and Miano machines, our tooling and accessories, along with our automation department offerings, all of our MCC technology. We also always have heavy dealer support to our IMTS efforts and knew we wanted to include our dealers in these tech days. Please enjoy this next demo. We invite you to ask questions live as needed. Our team is happy to answer any questions you may have. After each session, we will share some videos from our distributor team and also update all with our promotional efforts along with financing options. Thank you again for joining us in MCC Tech Days.
Thank you, Brian. Now we're going to demonstrate for the first machine, the M532. Showing you this machine is Jack McGinnis and Richard Arrett. We'll start with Jack. Take it away, Jack.
Good morning. My name is Jack McGinnis with Marubeni Citizen out of Southern California. I'm here to talk to you today about Citizen's brand new model M532 Type 8 machine. The M machine has been around since the mid-1990s. For those of you who have been around for a while, the first thing you'll notice on this machine is a much larger machine. I'm going to go through some general features that are different from the older machines, that are new, and then we'll get into more of the concept of the machine itself. The first thing you'll notice, again, much larger machine. Machine weighs about 9,500 pounds, much larger casting, much heavier than the old machines, allowing us to get into much heavier cuts and stability for nicer finishes when we're machining components. The other first thing you'll notice right out of the gates is a much larger door to access into the machine, allowing us to hit all sides of the machine very easily. In addition to that, our turret, our new turret, has now a tang drive for the live tools. Grab this in lieu of the older gear-driven heads, gear-driven tools, allowing us again to be able to drive more power into the tool, getting more aggressive cuts. The control is a new Mitsubishi 850 control. Offers us a touch screen so we can get around in different areas, depths of the control much easier. Pictures, and again, very good access for our operators, much easier to do. The M machines, as all Citizens, is a sliding headstock machines. I think most of you are familiar with the Swiss type. Our headstock in this machine has 12.5 inches of stroke, meaning I can get long, thin parts machined on this machine, and we're going to go through some of the aspects of that as well. So we have a sliding headstock, outboard. I bring you in here a little bit. We have our guide bushing, which is a support bushing. Again, we call it guide bushing. So we tighten that up around our material. And our tools off our gang block are set about 80 thousandths away from the face of that guide bushing. So we've got a very rigid setup. No deflection when I'm machining and turning. On gang block, we can put turning tools, we can put grooving tools, knurling tools, back turning tools, cutoff tools up on this block. Now this gang block moves in what we call a Y-axis, and then up and down an X-axis. So we virtually have, obviously, the Z-axis headstock, an X and a Y, so I can face, I can turn, do those type of operations. In addition, if I can bring you in here a little bit closer, we have X-axis live tools on this machine. We have 4 standard. So again, with my Y-axis, I could have material sticking out here. I could simply walk across a part with the live tool, creating a flat. I have full indexing on this, on the headstock, so I could machine a square or a hex if I needed to. I can, in addition, with my Z-axis and my Y-axis, I can come down with an end mill, and I can G2. I can circle interpolate a boss on a part. Or if I had drilled a hole, I can go into the hole, and I can true up that hole. Really a full machining center capability up here on this machine. So I've got my stick tools, we've got our live tools, and in addition, on the gang block up here, I've got a 90-degree head with 4 live tools facing front, 4 live tools facing back. This 90-degree block has a programmable B-axis, full B-axis. I can program this to any angle. So if I had angle holes, if I had angle flats on a component, I could certainly machine that. We can actually machine, if I had a sphere, a ball's shape on the front, I could actually come down and I can machine using that angle. We virtually have a 5-axis movement we could use in the front of this machine. And we're going to show a part in a little bit using my Z-axis, my Y-axis, my X-axis, my C-axis, and using the B-axis as well. Full 5-axis move. This may sound somewhat complicated. I've been with Citizen since the early 1990s. Citizen's done a very good job at this over the years. They have simplified the programming of all this. I'm not going to get into a lot of detail, but we call the front side, the axis I just spoke about, $1. If I could bring that up. My main program, $1. Richard will get more into that in a few minutes. In addition, on the M machine, we have a 10-station turret, live tooling capable on the front or on the back. We can put turning tools on this turret. We can put ID tools on this turret, facing the main or facing the back. The turret, in addition, if you wanted to load up for a family of jobs or many jobs, we have half indexing capability on this turret as well. So we have cell tool holders that have half index positions, so I could have ID tools off center, off half index, and really load this thing up if I wanted to. With all that said, this turret has its own Z-axis, a Z2, has its own X-axis, up and down, and has its own Y-axis, giving us full machining center capability on this as well with our live tools. So I talked about $1. The turret is now reprogramming $2. Very simply, what Citizen does, our cutoff face on our material is Z0. So we touch our tools off to the OD of the stock, and any of our ID tools off to the face of the material. Machine knows where that Z0 is. It also knows where all the tools are. So I can take this now, if I wanted to turn at, say, 4 thou per rev, and wanted to come in here with a drill and drill at, say, 2 thou per rev. And in fact, if I wanted to peck drill while I'm drilling at 2 thou per rev, we can simply link the turret up with a 3-digit code, and it will overlap its program over the main program. You don't have to worry about where all this is. The machine knows where it is. So I could be actually turning and drilling simultaneously. And if I'm drilling slower than the feet of the turning tool, you'll actually see this turret backing up. peck drilling as we went. So again, full capability, live tooling, turning, ID work off the turret. In addition to, we're going to get a little bit more into high pressure cooling in a minute. I'll talk about that in a minute. In addition to that, we've got a subspindle, full subspindle with a C-axis also. My subspindle programs are what we call $3. So I could come in, I can grab the material, and I could actually support. If I link the subspindle up at the headstock, I can now come in and support that in movement. It will follow its program. It will follow the main program, the headstock program, and just slave it. So we support the material so it's not whipping out on us. I can then turn, I can do any machining center operations, milling, whatever I needed to do. I can then come in, move forward, grab the material with my subspindle, cut off, and I could use the tooling on the back side of the turret, ID, OD, live, or if the turret is tied up at the front, I've got an additional stations up on top here. There's 3 stations, all live tool capable. On the front here, we're showing a 90-degree live head, 3 positions. We can set that at an angle if we wanted to and do angle milling, angle drilling. We don't have a tool in our center, but I can put stick tools in here. I can put live X-axis tools in here. And in the back, we've got a 90-degree static block as well. So again, I can give you extra tooling capability on the back here, so I can separate my subspindle out and give you free time machining in the back. So this machine is actually a 12-axis machine. Again, if I take a look, Z1, XY, B, C, Z2, X2, Y2, and Z3, X3, Y3, C-axis on the back. But again, Citizen's software, the architecture, simplifies all of this. We program to each section, and machine knows where the faces, the cutoff faces are when I'm in the back spindle as well. And we've touched the tools off. The machine will take care of all those calculations for us. So that's basically how the M machine works and how we can process parts through it. I want to talk a little bit about some of the things that Citizen has done over the years to help support robust setups and operating this machine. I'm going to walk over this way, guys, if that's okay. We offer high-pressure coolant pumps. We've been making high-pressure coolant pumps from the mid-1990s. These have developed over the years. We now have 10 line pumps, 2,000 PSI. It's got its own PLC. We interface this back into the machine control. You can turn these lines on and off through your program, making it very, very nice and simple. We can bring those high-pressure lines into different areas of the machine. Our gang blocks now support the high pressure, where we can now bring tools, put tools in, and we've got one tool company, there are many, but NTK now supplies, I don't know if you can see this, guys, take a quick look. We can put coolant right in through the tool holder itself and have high pressure coolant come out right at the cutting tip. That offers good chip control, and it offers good lubricity on the cut. So again, we're trying to control that process. So if we've looked at a component for you and we give you a 45-second cycle time, a 2.5-minute cycle time, whatever that might be, we want to control chips. We want to clear chips off of drills. We want to clear chips off of maybe our turning tools if things are getting balled up a little bit. We can do that with the high pressure. In addition to that, if I've drilled a hole in the main side, in the front side, and I come in and grab it with my subspindle, cut it off, and I've got it in the back, and I'm working the ID on the back, potentially I'm packing chips back into the subspindle, which may cause me a problem eventually to try to close that collet. So standard on the machines, we've got a pneumatic line that comes through, we blast the air through. We pull that off, we put a high pressure coolant through the subspindle. Again, now we can come in 2,000 PSI. So if I'm working the ID on the back, while I'm machining. We can blow a high pressure coolant through, giving us, again, good lubricity on the cut, and also keeping that sub-spindle clean, keeping that collet clean. So again, we can give you a robust setup so you can machine, keep these machines running. That's the whole idea. So a lot of capability on this machine. Again, for those of you who've been around for a while, much larger, beefier, strength, more robust tooling systems. We can really get aggressive with this machine. I'm just going to walk around the machine quickly if you want to follow me through. We've got a very large coolant tank. And if you were to buy one of these machines and wanted to add a chip conveyor in the future, it's all set, ready to go. You can just add this. This will accept it. In addition to that, we have standard 2 flow pumps in the back. Again, getting good coolant, good oil in throughout the whole machine. We have that in conjunction, certainly with the high pressure coolant. And a little further up, we've got 2 heat exchangers, one for each spindle. We want to keep the machine stable. Again, we've got a big casting for stability and for aggressiveness, but we want to maintain the temperature of the machine, and we can certainly do that. Citizen's done that with our heat exchangers back here. Walk back around the front. Oop. A couple other things I want to talk about, and this really relates to our entire line, not only the M machines. Citizen has done a good job over the years looking at applications and coming up with solutions. One of the things we offer are high-speed spindles, high-torque electric spindles. Again, we've been doing this for many, many years. A lot of tiny little medical parts we can get in, small little hinges and whatnot. We can get up to 60,000 or 80,000 RPM spindles. These are listed on our price sheet as if this makes sense, a standard option. So we've got them all set up. We have the interfaces all done. So we can just implement these with the tooling blocks to hold them and put them on the machine. You can buy these in the future as well on any of our machines if you have a need. The other thing that Citizen offers is what I call a convertible guide bushing. Some people might call it a chucker type style. When we put on a Swiss machine, our headstock always moves in a Z-axis, but we can pull our guide bushing out. That spindle nose will extend through. We put a little cap nut just to cover the space so we don't get coolant and chips into the back, and we can now make this really a fixed headstock machine. Again, we're still moving the headstock in Z, but now we're using a collet. That's right across our entire line. This machine, in addition, as all our machines, we can size it up. 32 millimeter machine, 1.25 inches, but we can go up to 38 millimeters simply by changing the sleeve in the main spindle, changing the guide bushing. And if you need it bigger in the sub spindle as well, we can put a larger 38 millimeter sleeve in that as well. So we can get you up to just over 1.5 inches on this machine. The other thing that Citizen has worked on and has been very popular as of late is what we call LFV, low frequency vibration. Again, we give you a process, we give you a cycle time. We want to make sure you get there. So high pressure helps us controlling chips. There's a lot of things we do that'll help you control chips. But now the LFV function actually allows us to set and come in and out of the cut a little bit. You can set the different parameters if you want to get a little bit more or less aggressive on this, and actually automatically break chips. We've sold quite a few of these in Southern California. I had one fella come back after me. He was so impressed with what it was doing on the front on an L32 machine. He was mad we didn't have it on the back. Since then, Citizen has implemented it on the back, and we've certainly installed it on his machine. Many, many, many of our machines, a high percentage now, go out with the LFV. Again, giving you a robust process so you can run. many of our customers want to run well into the evening and let these machines just go. We can do that. So the 38 millimeter LFV, high pressure convertible, high speed spindles, all things that Citizen brings to the table because of needs from our customers. So if you have something you're looking at, please let us come see us, let us know. We've got a full group back east. We've also got a very good group here in Southern California that we can think out of the box a little bit and come up with some ideas that really might help you out. With that said, we're going to show a video of a part. Where am I going here? Right here. We actually have a wave on this, and this is actually going to be a 5-axis move. Not many other machines of this nature can do a 5-axis move. We're actually going to move in C, Z, X, Y, and B, keeping this tool where we need to keep it to complete that wave on this part. So with that said, Richard, you want to go to the video?
As we said, we're going to show you machining a part on the M532. First off, let's show you what it looks like when we're doing a high-speed check function, checking for any errors in the program, such as syntax or queuing code errors. We shift now over to doing a face-off move on the machine. Can bring in two tools, an ID and OD tool simultaneously, using axis superimposition, a very powerful function of the Cincom control. Does multiple cuts at the same time. Back tool block is turning the OD of the part, the back side. Bringing the ID tool up to the front side. While that's going on here, we'll take a look now. We'll see this notching out as a rough notch, getting ready to machine a feature later on in the program. Setting a block on the backside, a live block to drill angled holes, fairly straightforward yet simple process with the Cincom control. You are doing another roughing out, getting ready to move into the 5-axis machining mode. Drilling angled holes on a Cincom machine is a straightforward process. A couple of simple commands. Your local application engineers can show you how easy this is to do. Starting the profile with a 5-axis machining, following it around. We start doing a little rough pass first. Come back around and do a finish pass right after that. And finish that off. Now, something we're able to do, the holes that we're drilling angle on the back side, now we can come up and chamfer them utilizing the gang tool. It's on the front side, so the main side spindle. Maintain absolute positional accuracy. The back block, the B-axis block can actually rotate 45 degrees on the back side. Come back around now, we're going to do a pinch drilling and pinch milling operation. These spindles line up exactly. We're going to turn the profile of the OD now, turning it down. Part on the left side is being ejected. The sub-spindle picked up in the basket, dropped in the part sketcher. Continue to profile the OD. Sub-spindle is going to come forward to grab the part, get ready to pick off. Right here, sub-spindle comes forward, captures the part, cut off, and we're done.
Thumbs up from. Hello again. Let me introduce Richard Everett. He's our Service and Applications Manager out here in Southern California. Richard's been running Citizen machines in his past on the shop floor for many years. He's also been with Citizen. Doesn't look that old, but it's
18 years.
18 years, so well qualified. He's going to get into the control a little bit more.
Hello and welcome to our event. I just want to go through a few control differences with this new machine, the new 850 control, the Mitsubishi control. What really makes the new M different is going to be the touch control.
Did it do okay?
You can touch between dollar signs very quickly. It's very quick to interact with this control. You can see on preparation, many of the screens are very familiar with what you're used to any version M, for that matter of fact. You're going to have more choices down here. What's going to be a little bit different here is you're going to have more choices as far as the turret. So this machine, the new M, has a tool library. The tool library quickly and easily defines tools that are associated with pockets on the turret. As you can see from the picture, is illustrating exactly what turret holder you're talking about in that location. This is twofold important because not only does it give you a visual representation of the turret holder, but it also defines positions, pockets in that tool holder, so you will no longer be required to put G50 shifts in the program as past versions. As Jack mentioned, the new turret tooling for this machine, the live tools are unique to the new M. Previous M32s, the tooling is compatible as far as static tooling and stick tooling that may be required for this machine. However, live tools is now the new tang drive that Jack showed you. As you can see with the new ID station holder, you can see all the designations for the different pockets, different tools. Whatever the tool may be, this is a standard X-Cross live tool. In this screen here, you can quickly identify the tool. You can scroll up the screen. You can scroll down the screen and identify the tool, exactly what you're working for. At MC Data, many familiar screens on this screen as any Cincom. You're going to have your material OD, your bar stock OD, your positioning point, your cutoff tool. All these are very familiar with previous generations of M. No different with this machine. Where you're going to see some differences is in here, and you're going to define your tools in here. All the tools in the library you can define quickly and accurately with no mistaking the picture for the tool that you're talking about. This screen is quickly accessed by scrolling through the pictures. You can touch on the picture and it shows you the picture of what you're using. The other benefits of this screen is, again, you have no G50 shift. The G50 shift will be put in the tool pattern for you, so you will not be required to put that into the program. As you can see, all the tool holders are defined. So for example, on this tool holder, there is no definition. If you want to use some special tooling you have, or if you do not want to use the predefined G50s in the machine, you can select this page, and this page will leave you to define the tool as you see fit in the program. So this information also holds true for the back tools. As Jack was saying, we have this back tool that is set to slant. You have a few options for this tool. It could be set to cross, it could be set to face, slant. You could set the tool to free tool if you have some undefined tool in here, and it will make it nice so you can come up with any numbers you need to set a tool. As you can see back again in edit, what's really nice about this control, I've spent quite a bit of time on this new machine. We set up this part, but transitioning between dollar signs, transitioning and placing the cursor is very fast. So I can transition and place the cursor right here, make edits that I need, and transition right to $2, right to $3 with a simple touch of a finger to the screen and make the edits that I need. The machine is very familiar again in program check. We still have program check, high-speed check function that is standard on all Cincom machines. So as we are familiar with this function, it allows the program to be checked in the background for syntax errors, syncing errors, and various other errors that may be caught prior to actually running the machine. Everybody's pretty familiar with the high-speed check, and you have the handle function. So the handle function is the same, and it allows you to crank through the program. And especially on the M, there's a lot going on in the M. You have $3 signs, you have a lot of axes moving at the same time. So the handle function is very nice to crank through the program. We're going to have another demonstration of that shortly on the L video that's going to be coming up in the live demonstration. But I can't stress enough with the handle, it's very nice to crank through the program. You can crank through a spot into the program that may be unfamiliar or maybe becoming close to interference. You can actually crank the handle backwards, removing the tool from the interference zone, hit reset, escape out of there, and make adjustments. You can also correct the program on the fly by pressing correct, and this will allow you to make edits on the fly, minor adjustments. If you see a syntax error that you made a mistake on, maybe the decimal's in the wrong spot, maybe there's a number wrong, you can quickly and easily make adjustments as you need. So many of these screens, even though this is a brand new Model M, all the screens are very familiar. All the screens and all the tool setting functions are the same. Still sitting on the top of this Mitsubishi control is our Cincom software, making it very familiar as to any old previous M. If you ran an old previous M, M2, M3, M4, you can walk up to this machine and still make it work because all the screen functions and all the screen mannerisms are still the same, even on this very brand new machine. I really like the new touch screen and the interface because it does make transitioning between screens and the data very quick and very effortless. All the safety built into the machine as far as cranking the handle and cranking through the program make it very nice. So Citizen has, with our Cincom software, we tie the programs together, as Jack was saying, $1, $2, and $3, with our G600 codes. So with the Cincom machine and the Cincom interface, the machine excels at this. It makes a very complicated machine with multi-axis very simple to tie these different areas together with simple codes, with simple G600 codes. And as you can see, I can scroll through this program simply by swiping up on $1. I can place the cursor wherever I want. If I still want to page down with buttons, I still have buttons available that I can scroll down. And as you can see, more G600 codes, G620. And in this mode with sync display, it makes it very visual for somebody to look at the screen and quickly recognize the programming, how it looks, how it's supposed to look, and make sure that your queuing is set in the proper order. It makes it a very visual, very quick access to the program. So again, to recap with the programming, with the G600 codes, when we come out and we train very well with teaching the codes and making sure these codes interface with the machine correctly and that they're understood. So basically the codes are meant to make the machine have very specific functions at very specific times, to making the machine easy to program, to making sure the machine is doing exactly what is required by using these basic codes. As with all M's, last part programming is a very good function. As you know, with the Swiss machine, typically when the machine stops, it has an incomplete part in the subspindle. With last part programming, what that allows us to do, it allows us to complete one complete cycle and make one complete part. You're no longer left with an incomplete part in the subspindle. So this is a function that we use in our programming technique for programming the M or any Cincom machine for that fact, that we can make last part programming work and you will have a complete product at the end, making setup times faster, making it more productive, and saving money because you're allowed to set up one part, get one part done at one time, one complete product. A few more screens, back to program check as I explained the high-speed check function. A lot of the other pages like offset are very familiar, and they're also touch interactive. You touch the offset page that you want, you can see it's highlighted, you can make your direct offset to these pages. Very simple. And all the pages here to the side, again, all touch, making it very fast, saving tremendous amount of time transitioning between pages setting up this machine. As Jack said, the new M is convertible to non-guy-bushing mode standard now. The drive shaft, easily to be taken off, put back onto the machine, making the machine go into non-guy-bushing mode relatively quickly, effortlessly. I just want to show you the Tang Drive tool again, because this is the tool that is unique to this machine, to this new M, with the Tang Drive. The Tang Drive, I was really excited about the Tang Drive system that came out because with this tool in the drive station, it doesn't bleed energy anymore. It's only driving the tool that's in the pocket, that's in the active station. You don't have drivetrain wear on turning tools that are no longer being used. So you may have the turret loaded up with tooling. However, only the tool that's in the active position is the tool that's turning, saving tremendous amounts of energy and power. So the main spindle, sub-spindle in this machine are 10 horsepower. The sub-spindle, the live tools are almost 3 horsepower on this machine. So the machine has tremendous amounts of power, especially with the new tang drive. Again, it doesn't bleed energy off as other machines have, and makes it a more robust situation for turning, drilling, milling, whatever the case may be. So I think we're going to take a few moments now, and we're going to have any questions and answers that you may have. I know Jack touched on the high pressure coolant. He talked about that. You know, if you guys have any questions, it's going to be a good time. I would like to just talk for a minute again about the high pressure coolant. As you guys are aware of, typically inside the machine, you have high pressure lines that would be sticking down from various manifolds in this area. As you can see, here's a traditional manifold that we have. It would be, you would have a line coming out here, a steel line coming out here, feeding the tools. But as you can see, the regular stick tools have no manifold coming down because they are plumbed directly through the tool block from the manifold on top. It makes a very clean interface for adding high pressure and utilizing high pressure. There is no more adjusting lines, no more lines getting in the way. You can deliver high pressure coolant accurately and directly to the tool tip without fail. Turret tooling has the capability of high pressure through the turret. There's a plunger in the turret that allows direct coolant flow to the individual tools, cutoff tool, some drilling stations, and some tooling through. So it's very neat. It's seamless. You won't even see that it's happening. It'll feed the turret. It'll feed the turret directly with high pressure coolant. And as you can see, the manifold here for the back ID block. You could plumb high pressure lines through here. You have some ports up here for allowing pressure through. It's a very nice setup, very clean. Allows very easy use of adjustment to make sure that the coolant is flowing where the coolant needs to go. So I'm really excited about this new system with the toolant. NTK was a big part of this tooling that we used on this machine to get the coolant through the tools. And again, you know, with the pocket where you place your tool has a small hole that lines up with the hole in the gang tool block and allows, again, direct access. So that also means if you do not have a tool like that, you can still run the manifold as you have in the past to give you direct access to coolant at the tool tip, no matter what tooling you use for this machine. So we're going to go ahead and take a few moments and have time for questions and answers. Looks like we have one question. Adaptive guide bushing. So the question is, do we have an adaptive guide bushing? As I understand, the adaptive guide bushing is under development for this machine. And if it is not currently out, it will be shortly, making the new adaptive guide bushing available for this machine. So it looks like we have no other questions. So that's a good question. So can we output the tool? Yeah. So yes, so the tool data, so like any other Cincom, when you input and output the program, you'll notice at the end of the $3, there's some information there, some variables. So on this machine, yes, absolutely. All the tooling library will be output with the program attached to the end of the program, including all the tool library that is currently in this machine. So if you were to take the program out and you put the program back in the machine, all tooling library information associated with that program would go back into the library, back into preparation as with previous machines, and including this machine, it includes the entire tool library that you have selected. I hope that answers that question. Do we have any other questions for the Q&A section? One more moment.
Richard, if I could, I'd just like to make another comment. Again, here at Marubeni Citizen, we've got great machines, bar none. I've been selling Citizen machines since 1992. It's a wonderful company and we've got wonderful products. But beyond that, we've got a wonderful group of support and training staff.
Thank you.
Citizen has training for life. Citizen has an absolute commitment to supporting our customers. If our customers are successful, we're going to be successful. And that's what we believe. Citizen, our 4 offices, New Jersey, New England, Chicago, and here in Southern California. We've had these classes. We just did one online. I don't know what this virus, where everything's eventually going to go, but we just did an A20 class online, which is opened up to the whole country.
Yes.
So we're going to probably get a little bit more efficient at this and continue to offer this. Also, most of our guys certainly have come off the shop floor, know how to run these machines. We know how to process parts. We like to get together with our customers, do a little round table.
Yes.
Let's help you figure out how we can better produce your parts in an effective way. We're pretty good at it. Thank you.
Thank you. So at this time, we're going to close question and answer. We're going to check Q&A one more time to see if we have anything. So there's no Q&A at this time. Hold on one moment. I'm sorry? Close up of the gang plate coolant, sure. So they want to get a close up of the gang plate. So see if you can get close to this manifold up here. We have this manifold here for the live tools. Live tools here. Okay. So thank you for attending this section. I hope this has been informative, entertaining. We have learned a lot about this new M over this last year. I'm a big fan of the new M with the new control. I think it makes it very easy to set up. We'd like to thank you for attending this session. Give us a moment here and we're going to transition to the next slides. And again, thank you very much.
As Brian mentioned earlier, we have participation in many of our dealers. They've always been active participants in the IMTS events. They provided us with several videos that we'd like to show. The first video we'd like to show today is from Spinetti Machinery, one of my dealers, who I must give some kudos to because Paige and his team always make me look good. Got a video showing us gear hobbing, so if you could switch down to the next slide to show the video, that would be good. Take it away.
Welcome to Spinetti Machinery. We are a very focused distributor concentrating on Marubeni Citizen-Cincom CNC Swiss, Citizen Miano CNC lathes, and FOBA laser markers. We pride ourselves in representing the finest equipment in their categories, attention to detail, and providing the highest level of service for our customers. The turnkey project we did for this customer is one of many examples of that. Now let's look at today's demonstration. We are pleased to have you with us today as part of the Marubeni Citizen-Cincom IMTS Demo Days for 2020. Today, we will be demonstrating a gear hobbing application on the Citizen L220 Type 10. A little about the machine. The L220 Type 10 is a 20 millimeter machine with a 25 millimeter upgrade option. It has the capacity of up to 34 total tools and has a Y2 axis on the sub for additional machining capability. Some features of the beveled gear project. We are using a gear hob attachment from Marubeni Citizen-Cincom New England division. We are using the LFV function or low frequency vibration. That's part of the latest in the Cincom technology. The gear cutter is a special 3-tooth cutter from Gen Swiss. The goal of the project was to successfully make a pair of identical bevel gears to mate together in a housing designed by the customer. Originally, the customer was making a single gear in 5 operations, whereas we are now making the gear in a 1 complete operation. This project is this beveled gear, which is not a common thing to do on a screw machine. This particular beveled gear, instead of being at a 90 degree, it is at a 57 degree, which is even more unusual to run on a screw machine. This particular beveled gear required us to use this 3-tooth cutter, which acts more like a single tooth cutter than the normal cutter that we would use for a spur gear. We also 3D printed this particular fixture to hold the 3D printed gears we made of their printed part so that we could get a better understanding in the very beginning of this project. The customer's actual unit that they're doing this in is this one here, where you have 2 of these side holders that hold the gear that then fit into the housing, whereas then the beveled gears will drive each other. Thank you for joining us today. I hope you got a small glimpse into what the Citizen-Cincom Swiss CNC machines are capable of. Thanks to the Marubeni Citizen-Cincom New England office for the gear hobbing attachment. Thank you to Gen Swiss Tooling for the 3-tooth hobbing cutter and the turning tools, and Harding for the collets, and our customer for allowing us to showcase the part. If you have any questions, visit our website at spinettimachinery.com or send us an email at info@spinettimachinery.com. Have a great day and stay tuned for more to come from Marubeni Citizen-Cincom during IMTS week.
Citizen Machinery and Marubeni Citizen-Cincom are constantly innovating and developing new products and processes to improve your productivity. We're going to show a video now of a new process being developed for the C320 bar loader, and Mark Zarbuck will explain that in this video. So let's run that video now, please.
Hello, and welcome to MCC Tech Days. My name is Mark Zarbuck. I am the bar loader product manager for Marubeni Citizen-Cincom. Today, I would like to show and explain a new technology that we've been working on for future development on our A320, C320 bar loader. We have developed an Ethernet link between the A320 and the C320 that will give us almost real-time communication between the machine and the bar loader. Not just signals, but actual data. With this, we can now send information from program to the bar loader by using macro variables like overall length of the part, short feed safety, long feed safety, and torque setting for the pusher. We also receive from the bar loader using macro variables like bar remaining, parts remaining, and pusher position. And here's an example of almost real-time info sent from the bar loader to the machine. As I move the pusher by hand, see custom macro 443. Now with this type of information, being sent through the program. If the operator or the setup person forgets to send the bar loader info, the information will be sent by program. We are also working on having this information of parts remaining and pusher positioning showing up on our operator screen. Another new feature that we'd like to add to our bar loaders is last bar sensor. So if the lid is closed and the machine is in automatic and the last bar is loaded into the channel, now with the lid still being closed, we have a warning light blinking that states that there are no more bars left in the bar loader. Please be on the lookout for this option and Ethernet connection between the C320 and the A320 in the near future. Thank you for your time, and please continue on watching the MCC Tech Days. Thank you.
I know you all got real excited about the M32 from the demo that Jack gave in the video we saw, but to further increase your excitement, we've got another demo we'd like to show of the M32 in action, doing an even more complex part than we just showed. So let's watch that video right now. Since we are a live event, we do encourage questions at any time during the presentation. A couple of questions came in after the M32 demonstration. First of all, we have confirmed that the adaptive guide bushing is now available on the M532. Somebody was asked about that. Another question came in, is there other gang plate tool holder size options like on the L20? To my knowledge, we do not have any other options at this time. Somebody else, Brian, you may have an answer to that, but I don't believe there are at this time. That doesn't mean we can't make them for you or that there won't be some available in the future.
You are correct. So they're 5/8 square on the gang plate, and that's our only options.
Right. But as always, if you do have a special application, please submit that to your local dealer, who will talk to the regional sales manager. We'll bring it up to our tech center because we have designed special plates for other customers in the past, so it is a possibility. As we've shown, the M32 is Citizen Machinery's the most sophisticated machine. Our most basic machine is the A320, very simple. Our dealer at Dynamic Detroit, though, came up with a very innovative, clever, creative process on the A320 to show you just how sophisticated this machine can be, even though it is the least sophisticated machine that we have in our system. So I'd like right now to show this video that Dynamic Machine Detroit made for the A320. It's pretty exciting, so take a look at this. And roll the tape, please. Not only did that video show you the level of sophistication that even the most basic Citizen-Cincom machine is capable of, I think it also demonstrates to you the level of sophistication and expertise that our dealers are able to bring to you. You'll see other videos showing equally creative parts. So bear that in mind as you contemplate your next purchase of a Citizen-Cincom or Citizen Miano machine, is that all our dealers are highly skilled and very capable of supporting you. We're scheduled now to start the next L32 at quarter past the hour, depending on where you're at. We have a few minutes. As this isn't a live event, if you have any questions regarding what you've seen so far or anything else about MCC or our dealers, please feel free to ask that right now. We'll do our best to answer them. Otherwise, we're going to take just a few-minute break. We'll be back at a quarter past the hour and do the L32. So if there's no questions, we'll just sit here for just a few minutes while we reposition the cameras and get ready to go at 15 after. Thank you. Okay, I think it's time now to start with the next segment. Are we ready to go with the L32, Richard? If we are, let's transfer over to Mike Maldonado, who's going to talk to us about the L32 Type 10.
Hello everyone, my name is Mike Maldonado and I'm with the MCC Group in Fountain Valley, California. Welcome to the MCC Live Tech Days event. I'm here today and my goal is to introduce you to the L platform of machines, and there's 3 different varieties. So I'm going to walk you through the differences of the 3 types, and my goal is to enlighten you as to what can be done with these particular machines because they're quite versatile, powerful, and accurate. Okay? The first machine that we have is going to be an L32 Type 8, which is our entry-level machine. Now, the big difference between the L32 Type 8 and the L32 Type 10, which is what we have here, is that as opposed to having driven spindles, we have a back block with 5 positions that are static, so there's no live tooling in the back. We still have a gang slide similar to this, and with 6 positions and 5 driven positions. Over and above that, we have an additional unit on the back, which enables you to plug in what we call a driven dog leg, and that will allow you to put motorized tools and utilize them on a predetermined angular setting, okay, which is done manually. On this particular machine, on the sub spindle, we have a 3 horsepower continuous duty rating motor, and it's 5 horsepower, 30-minute rating, 8,000 RPM. And on the sub spindle side of the machine, we have an X, Y, Z, and C axis that you can work with, okay? On the primary side of the machine, we have our guide bushing side, which does have positive pressure, which enables you to utilize high pressure coolant without having to worry about any foreign materials or matters getting into the guide bushing itself. We also have 6 turning positions and 5 driven positions to do your cross working. Now, on the Series 12, everything is the same as this, But in addition, you will have a programmable V-axis on the very back side, and I'll show you where that comes in a second. I'm going to do a brief walk around on the machine. Let me first start by saying the casting is big, rigid, and thermally stable. We have hardening ground waves, and we have roller packs on those. So the end result is a machine that is extremely quick, accurate, and thermally stable. We're traversing the axis at a rapid rate of 32 meters a minute. Okay, so with that said, I'm going to go around and show you a little bit about the machine. All of the L family comes with a part conveyor. Okay, we also have here a chip bin, and the chip bin is where we extract the chips after the parts are manufactured, or we can take this out and put in a chip conveyor for unattended style manufacturing. Around this side here, we have a fine particulate capturing device. So as the coolant flows through the machine, the particulate matter, the fine particulate matter goes into this bin to keep it segregated from the coolant. We also have here a spindle cooler, which helps also in stabilizing the machine. Important. Like I said, it's big, it runs fast, and it stays stable. Back here we have the guide bushing, where we actually will detach the belt. We can take the guide bushing out of the housing and convert it to non-guide bushing mode. Okay, the difference between one and the other, if you're running in guide bushing mode, you can machine parts up to 320 millimeters in length. If you machine in guide bushing less mode, non-guide bushing mode, you can machine parts up to 80 millimeters in length. Okay, the single stroke of the headstock is roughly 12 inches, and the diametrical capacity is 1.25 inches, and there is a 38 millimeter conversion kit, which enables you to get up to about 1.49 inches diametrically. Okay, this is the pneumatic logic panel, which controls a lot of the functions of the machine. And then back here, we have rollers that are used in stabilizing the bar stock. And this is important because when you're trying to hold tents on a diameter, this helps you a lot, especially if you're running in non-guide bushing mode. Okay, here we have a servo motor, which is on our cab bar loader. The cab bar loader, what makes it unique, it's an additional axis for the machine, and basically maintains the positioning accuracy and synchronizes with the headstock. So everything is always moving and conveying back and forth with their position. So we always know where the bar and the headstock are. Okay, I'm going to be now, this also, by the way, is the logics or the brains of the bar loader, where it controls the different functions of the bar loader. So I'm going to walk around now the bar loader and meet you back on the other side, and we'll continue the discussion. Okay. Okay, I'm going to do the okay, now I know that a lot of you folks have automatic bar loaders in your shop, but for those of you who don't, I'm just going to recap quickly what it basically does. This maintains the manufacturing cycle continuing until the bar stock runs out. The bar stock is put into these channels here, and the number of bars may vary because of the diametrical dimension of the bar. As the bar is signaling for a new, as the headstock signals for a new bar, basically the remnant is pulled back and it's deposited here in the remnant retract bin. Once the remnant retract bin, it's sure that it's released. The pusher tube comes all the way back to the home position. The channels open up. The new bar drops into the channel. The channels will then close down over the bar again. The pusher tube comes over the bar with a collet, and it pushes it into the work area, and we start the manufacturing process again. And it will continue to do that until such time as you run out of bar stock. Okay, so with that said, we'll go ahead and go towards the front again, and I'll get a little bit more in detail on the machine. Here we go. Okay. 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 Now with these machines, there's one of our companies called CMA manufactures all of the attachments for us. And what that does for you basically is it enables you to be sure that any accessory that you put onto your machine will fit without any problem. The other very important thing as far as Citizen goes is that you have a single source responsibility for everything from the bar loader to the chip conveyor. So all you have to do is make one phone call, whether it's a bar loader, control, headstock, machine, programming, anything that you may have that you have a question on, we're there to support you. Okay, we have lifetime training. And again, it's a one-call deal. You just basically call in and we'll take care of the problem for you. Okay, now, as far as accessories, we have a large array of accessories to help you change the configuration of the machines to better suit the part that you're going to manufacture. Okay, because the whole idea between these machines is to produce the part in the fastest cycle time. So what we do is we try and have a ratio of 50 to 50%, which is ideal. Obviously, we can't always get to that, but that's what our goal is. So back there are several different styles of what we call dog legs. There are driven dog legs. There are some with 3, there are some with 6, and there are some with 4. Also with different types of collets, ER11s and ER16s. Okay, that's used for the different types of tools. Those are mounted on the back side there and can be inclined manually at an angular position to facilitate angular drilling, centering, deburring, tapping, whatever you may like to do. It's also modular from the standpoint that you can convert it from a conventional 3-position stack on the dog leg to, on the pod back there that's motorized, to have up to 14 units, 7 on the front, 7 on the back, and they can be motorized, and they are completely modular. Okay, so with that said, you can actually change the configuration to suit the part. All of the attachments and accessories are manufactured by Citizen, for Citizen, warranted by Citizen, and you know, there's never an issue with regards to fit on the machines themselves. Now, with that said, let's go ahead and show the tooling accessory slide. Hey, Richard, can you show the slide, please?
Okay, Mike, I don't know if you're able to talk about that slide. Richard, put the slide back for a second, okay? So we just talk about that.
One more thing that I want to talk about is a feature that we have on our machines is called LFV. That stands for low frequency vibration machining. That
Mike,
is a
Mike, excuse me a second.
Although a lot of our competitors are trying to emulate that, ours is totally different.
I'm sorry for interrupting. We wanted to talk just a little bit about this slide here to show you the layout of the tools. The back tool block you see there, we've got some live spindles. In addition, what was shown in the live version was a crossed milling or slotting attachment we can add onto there. We can also put some tools, as Mike was talking about, in the gang tool block you see up there in the top left-hand corner, some different configurations, some angle tools. We just wanted to give you a better idea of some of the tooling configurations. Okay, back to you, Mike. I'm sorry. Take care.
Again, I'm back again with you, and I'm going to go over one more feature that we have, and it's called LFV. That stands for low frequency vibration machining. And essentially what it boils down to is that it gives you the ability to program your chips. And by that I mean by increasing or decreasing the RPMs or the feed rates, you can change the way your chips look. And as they break up, they'll fall away from the workpiece and will not wrap on your parts anymore. So whether you're running A286 or nylon, you will not have ship wrap anymore. It also gives you longer tool life, and it's available in 3 modes. We have one for drilling, OD turning, and for threading. And it is available now on the primary, which is the main side of the machine, and the subspindle side as well. Okay, now I'm going to show you a part that we did. It's manufactured out of nylon. It's black nylon. It's extremely soft, and it's very conducive to wrapping chips around the tools with a soft material. So what we're going to do now is show you a video of this part actually being machined, both with the LFV and without the LFV. And again, it's something that is manufactured by Citizens exclusively for the Citizen product line. Again, I urge you, if you have questions on any of our products, accessories, call the local distributor, call the factory people. We're here to help you in any way that we can. Okay, so with that said, can we roll the video on the part, please?
As Mike told you, we're going to be demonstrating a part, turning a part with using LFV on the L32 Type 10. Notice a large workspace area, easily accessible to get the tools. So we're going to face off. We're going to start with an ID move. Note how small the chips are coming through the drills instead of long stringy chips as you would expect. They're very small, very controlled. Also using axis superimposition so we can do 2 drills at the same time. Turning, same process, very controlled chips. As you know, with machining plastics, they can be very problematic, creating a real bird's nest. This isn't only limited usefulness for plastics, it can be used in all types of materials. See how the chips are just flying off there, very small, very controlled. This works really, really well, as you can see in a second about with grooving. Grooves can be very problematic with chips wrapping up in the grooves, difficult to get rid of them. Cutting down. The Type 10 and 12 now have LFV on the subspindle side. You can see here, controlling the chips as we do an OD turn. Not a problem with long stringy chips wrapping around the part. Very controlled as they fly right off. ID boring, same situation. Very controlled chips. Not getting long stringy chips. Not going to have a problem with chips being wrapped around the tool when the parts are removed. Coming back around, cutting off. Again, with LFV, you don't get the problem with the chips wrapping around the cutoff tool as you could with other materials or other operations. And it's done. We have another video right now. We're going to show you what the same process is doing without the LFV, so you get an idea of the contrast of how the different processes, the results of different processes. You note here, as you're drilling very long, stringy chips, they'll tend to wrap around the drill. You'll have to stop the machine frequently to clear the chips off the drill. Same situation here as we're turning, very long, stringy chips tend to wrap around the tools. Could become a real problem wrapping around the part. As you see right here, make it difficult to pick off a part without damaging it. This is all done without LFV, so I hope you can see the contrast and the definite improvement that you get by running the low frequency vibratory cutting motion. There's that bird's nest I was talking about, just wrapping around the part. In a lot of cases, you'd have to stop the machine after every part to clear that off. So that being said, we'll go back to live to the video of the machine, and we'll have Bailey Stump doing a demonstration of some of the other features of the machine. So let's talk to Bailey now. Take care.
Good morning, I'm Bailey Stump. I'm an applications engineer for Marubeni Citizen here in Fountain Valley, California. And today I'm going to demonstrate some of the ease of use features of the Cincom control. And I'm going to start first with just basic tool setting. Basic tool setting first starts out in what we call the machining data page, where we have input our stock diameter. Then what we have is the preparation page. And this is where we do all of our tool setting. So right now, I'm going to install a gang tool at position 6. So, it's very easy to work with. I'm going to move the cutoff tool up. And one of the neat things about this is that I can actually move the material in and out. I don't have to go to the manual page if I want to get it back even with the guide bushing. Very intuitive. I'm going to call it tool 6. You notice that there's a graphical display here, probably too small to see, but there's a graphical display here where it actually shows you what position you have highlighted here. I'm going to call that station to position. I'm going to jog the material out, again, not having to go to the manual page. And I'm going to perform an operation what's called man set. And I'm going to select the option diameter. The gang plate comes down. And at this point, I simply set the tool to the top of the material. Got to hand tighten the screws, and again, depending on what you're doing here, the machine knows which axis you want to move. Move it off the material. Tighten the clamp. That tool is now set. Top of bar is what we call it. So at this point, I'm going to call up the cutoff tool, which every program starts with. Jog the material out, and now I'm going to perform a cutoff operation. All done within the preparation mode. This operation can be performed at any gang tool position, so if you wanted to do a face cut to check center, there's other options for setting center as well. So at this point, I do what's called a start position. The headstock drops back to the machining data length, or the machining length, which is your total amount of material used to make the part. So let's just pretend that that was the last tool that we set and we're ready to check this setup, this program. Cincom offers an operation mode called program check. It's an awesome safety feature. It provides multiple ways of going through and verifying your program, even before you actually cut material. One thing that's also cool is just in the basic edit mode, the control will catch syntax errors and highlight them. So if you have like an extra decimal point or something like that. They even give you a description of what the issue is. Going back to program check, we have a mode that's called high-speed check. And what that does is it simulates the part program. It runs the part program. The machine does not actually move. It just runs through and checks for things like sync issues. If you have a queuing code that's off, or if you have interference in G41 or G42, it will catch it in high-speed mode. So, with that being said, so now it's running through the program. So it comes up with an alarm, compensation interference, and $2. So at this point, hit reset, go to edit, select $2, Well, it's not showing it. So anyway, I know what the issue is here, is that I have too big of a radius offset. Go back to program check. Let it run through again. We'll do this until it gets all the way through to the end of the program. Here, we see that we have a sync code that does not belong. Again, it makes it very easy to catch things before you're actually cutting material. It's a nice, safe feature, potentially save you a lot of money. Go back to edit mode. Go back to program check. It's going to run through again. Let's run through the whole program. Simulation has completed. Now, the next step is actually cutting material. Cincom Control offers a handle feature in program check mode to where you can actually handle through the program. As you rotate the pulse handle, it advances through the program. You can adjust the speed at which it moves using your buttons here. What is a very awesome feature of this is that as I'm running through the program, I can reverse, I can go forward, I can let it off, no movement is happening. I have complete and total control of the advancement of the program. Again, if I see something I don't like, I can reverse it. Another great feature is correct. You can actually correct on the fly. Single blocking it, going it through, looks okay. I see something I don't like, so I go to correct. I go to the issue. I've just made an edit while the program is running. I go back to normal operation. Finish that block. Now I can continue with running the program. So it's very safe. It provides you an awesome way of making sure that your tools are going to get through the cuts okay. You're not going to damage the machine. And like I said, potentially save you a lot of money and a lot of heartache. So that being said, that pretty much concludes my demonstration of the basic tool set and the program check mode. So I'm going to open it up for any questions anyone might have. Okay, well, I want to thank you for joining us today, and please stick around for the B&J 51. Thank you very much.
Okay, thank you, Mike and Bailey. I want to spend a few minutes just talking a little bit more about the LFE, the low frequency vibratory cutting that was mentioned. Richard, if you could just pull up the next slide for me, please. Okay. LFE is a Citizen chip breaking technology that was developed and introduced in 2014. The process is actually an axis oscillation, which creates an air gap in the cut so that as it oscillates, the chip is broken off. There's 3 modes in this function. It oscillates with the number of oscillations per the revolution of the part. There's a number of revolutions per oscillation, and it's also effective with threading. And it's possible to do 2 axes simultaneously, We can also use this process on angles and radiuses. And it does work very well on tough materials. We demonstrate on plastic just for the dramatic effect, but it does works very, very well on all sorts of materials, stainless steels, alloys, aluminums, titanium. It's a very good process. Next slide, please. In this slide here, you'll see a difference without LFV and with LFV in terms of the chip. One of the other things you'll do is just a side benefit is you don't have as many large quantity of chips to deal with because they all come out very small, compact, so you don't need as much space to handle it. There's also some savings in not cycle time, but a throughput time because you don't have to turn your machine off to clear chips off your tools. The people have found increased tool life, less edge buildup on the tools using the low frequency vibratory cutting. To give you a little bit better idea of how it works, I'm going to show you the next video of demonstrating at the real close-up of what the LFV is doing so you get a better idea of the function. So show the video now, Richard. Okay, one other thing I forgot to mention that I'd like to say is that the LFE is not just a software turn on options. These machines were all built with the special purpose built with the hardware and the machine to accommodate this low frequency vibratory cutting. It is actually built right into the machine to give you added strength, and it will not diminish the life cycle of the machine at all. So this is not just a software option, but it's actually built right into it. Since we are discussing the L32, I would like now to go to a video that our friends at Concentric have done showing a special process of eccentric turning on the L32. So let's watch that video right now. final machine we're going to demonstrate today is a Miano. So we're going to show you a BNX to kind of whet your appetite for what a Miano can do. This is the BNX 51MSY. I'm sure the rest of you will agree with me that not only do our distributors have some creative videos and some creative parts, but they've done a pretty good job of selecting their background music. This last video makes me feel like it's back in a 1970s disco dance party. Anyway, right now we are scheduled to start at the top of the hour, 3 o'clock. We're going to take a little short break and then we'll be back and see about 7 minutes. We should be starting. So let's just take a little break right now and we'll be back at the top of the hour. Take care.
And Glenn, there was
Yeah.
one question that I'll
okay.
announce and I'll answer here.
Okay.
So if somebody asked, while using LFE function, can we perform eccentric turning operations?
Oh, yeah.
And the answer is that eccentric turning is really a C-axis or milling operation that looks like it's turning, but it's using the C-axis. An LFE is engaged with the full spindle rotation. So those two functions are separate and they are not put together. So you could program it yourself, but not through LFE. Okay. So thank you for the questions. And if you do have any more, please ask them. Yeah. And we will take a break, as Glenn said. Thank you.
Yeah, we'll keep things open for questions. If somebody asks something, we'll break in and answer the question during the break. So feel free to ask. Okay, we're back live now, and I'd like to introduce Han Fan, an application engineer at Fountain Valley office. He's going to start off a demonstration of the BNJ 51SY6. So let's go live to Han now, the BNJ.
My name is Juan Fan. Again, one more time, I'm working for Marubeni Citizen-Cincom in Fountain Valley, California office. And today I'm going to introduce to you my most favorite machine, and it is the Citizen Miano BNJ 51SY6. So this is the one of the most sturdy and heavy machine. As I mentioned, because all the casting right here, it built up at the box weight all the way around, and its weight 11,687 pounds. On top of that, we have 80 gallons coolant tank capacity. So it adds a lot of weight on the machine as well. So with that, the machine can handle a very big and heavy cut. So another thing, as a machine provider, we understand a lot of machine shop out there concerned about the spaces that the machine gonna take place. So let's look at the size of the machine first. The machine is 103 inches by 60 inches, and it is 67 inches high. So it's very good size of the machine for a lot of place. So let's look at inside right here so you can see what I mean. So inside right here, we have twin spindle and twin turret. And then both of them, it can work independently, separately. So that means literally we have two little machines fit inside of one machine right here. And then this machine was built to run the bar stock OD with the unattended mode. So with that, we need to hook up the machine with a bar loader. So bar loader, we can come up with a different style with the bar loader, which is can give you allow you to run 3 feet long bar loader up until 12 feet long. So all the decision is going to be up to you. You're going to make the choices what it fits for you. All right, let's look at inside the machine right here. The main spindle right here, it allows you to run the bar stock in there up until 2 inches in the OD, which is 51 millimeter. And then it's using the S22 collet pad. Same thing like that, but in the sub spindle right here, we're using to pick up the part and transfer and do whatever at the back side right here need to do in order to complete the part. But it is 42 millimeter, which is can go up until 1 inch and 5/8. But then we had an option that we can upgrade this one up until like 2 inches as well, and using the same collet pad like the main spindle. Both of the spindle right here has had the capacity to run up to 5,000 RPM. And then whatever the RPM that you command in the program, the machine it can get it very quick in just a second. In order to show you, I'm gonna go right here. The control panel has had a function right here that we can turn on the spindle in the manual mode right here. So first thing, I'm gonna go to spindle 1. By simply selected the spindle 1 right here. And then right now I command the spindle 1 at 3,000 RPM. As soon as I hit start, and then just in 1 second, you can see right here, the spindle RPM reached to whatever we commanded. So it's very quick. And then the same thing in the sub spindle, if I commanded 25,000 right here, 2,500 right here, and then hit start, it also get to the point very quick too, just in second like that. And then we can stop it. Let's look at the machine right here inside. The machine has 7 axes. I can show you right here. So the main turret right here, it can travel in and out with X1 axis, up and down with Y1 axis, and then side by side like this with Z1 axis. The sub turret right here, it is stable turret. It will not move. Can only index to a tool in order to cut. But then the sub spindle right here, it can travel like side by side this way, or you can say forward and backward with the Z2, and then this way with the X2. And then both of the spindle has had capacity with the full C axis that you can command up to 0.001 degree. So that's a very good advantage for you right here, that you can use the milling interpolation, which is one feature. It comes standard with the machine. And then also we have another feature is helical interpolation too. It used to be the feature that you had to pay in order to get it. But then just like a lot of function is now is standard with the machine as well. So with a machine like this, it's running so fast, and when you index the tool and in the rabbit mode, everything is become very fast, just like the main spindle right here. The X2 and Z2, it can travel 20 meter in just a minute. So just imagine that is really fast. But then this machine has had a lot of feature that concern as a safety feature for this machine. First thing we can talk about is this thing right here. It's called the cutoff confirmation device. So what it does, the cutoff right here, when it command in the program, it's going to shoot out, and if it see the material in the front right here, and it say, okay, after the cycle time, maybe the part is not separate from the sub spindle, from the main spindle. So something happened right here, and we'll say, okay, all right, stop the machine right away, and then say, okay, something wrong. And then you can like go check, maybe you can just replace the cutoff tool. And another thing is we have M code also. The M code is used to check the rotation of the sub spindle, and then also say, okay, if after the cutoff operation, if the tool is breaking or not, it will stop the machine. So we have double side safety check. One is on the top of the program, one at the bottom of the program, is make sure everything go in the correct way. So a lot of things is going to be safety on this machine, and then you can be sure that the limit of unexpected thing can be limited to the least. Another thing that this machine has is called collision buffering. What is collision buffering is when you have the machine travel in rapid mode, and for some reason you have the tool hitting some material like unexpected. Okay, the machine, it will generate it's actually decelerate the feed rate, and then it's also the same time it create another force. It's going to the opposite direction in order to stop the machine from getting hurt. So this machine is really like safety, to run and operate, and then running around like that. So the next thing I want to talk is the turret right here. So the turret has had 12 stations, and you can see right here, as station you can equip with single tool like holder or maybe double holder, and sometimes you can have the front turn right here and 2 ID in the back side too. And then we have another holder which is called a quattro holder, which is can use up to 4 tools on one station. That means even the turret is had only 12 stations, but you can have a lot of tools mounting on this machine. And there's another thing that we want to say right here. Each of station right here, we can equip with the live holder. What I mean like that is the turret right here is built with a tank drive. So each station can be run dependently. It will not follow whenever you put the live holder in here and you turn it on. It's only that the station that you turn on, it will rotate. The whole thing, it will not follow. So that's a tank drive. And then the sub spindle right here is at A station. And the sub turret, I'm sorry. The sub turret right here now is at A station. And then 4 station is live. And then 4 station is static. But then the static station, you can have the double plane holder equipped on that. And then all the tool right here for the main spindle and the sub spindle using the 3/4 inch shank. And then for the ID tool, it's going to be 1 inch diameter ID shank. All the live tool on this machine is 25 pneumatic, and then 3 horsepower by itself on the live tool on the turret right here. So it can handle quite a bit like cut with the milling interpolation on this machine with the live tool. So one more thing that we want to talk about is, I mentioned earlier we have a quattro holder. What is the quattro holder is sometimes if you run out of the tool that required for the sub spindle working right here, you can borrow from the main spindle right here. the main spindle can use the tool in the back side right here in order to work in the back spindle. And then sometimes you can do as we call it simultaneously. So simultaneously, it can happen either with the static tool or the live tool as well. So with that way, we can cut the load of the cycle time, and then we can share the cycle time for the both sides. And since now, like in the back side right here, you have a lot of live tooling capability, and then you can share the load as well. So what is the main goal of this machine is we want to cut down the cycle time at least as much as possible. So with the idea that the main spindle and the sub spindle can using both of the turret working independently to have the machine always busy inside, and then you don't have to waste time around to waiting for another another spindle in order to work. Another thing is really good with this machine is it come up with different type of coolant. So we have the flood coolant right here for the main spindle, and the flood coolant for the sub spindle is all separate. You can program it on in handle one, in head one or head two. It's all separate to control by the M code. Another thing is inside the sub spindle right here, we have the flood inside the flood coolant that go through the sub spindle. It helps you to flood all the chips out, so help the sub spindle is always stay clean. Another thing for the high pressure coolant that we can have through the turret right here, and it has 150 psi. It helps you to blow all the chips on the tip of the tool that need to require sometimes you turn some material very sticky, and then it might stick on the tip of the tool. So that way we can make sure that everything go right. So one more thing that I want to mention right here, the machine comes standard with the part catcher right here, and then also the part convey, and then also with right there, we call it the chip convey. So everything is standard right here. You buy it and then you get all of it with the machine. You don't have to purchase any option, anything at all. So that is all about overall about the machine. So the next thing I want to go over is all the feature that we have here for the machine. So the machine has a very good feature that's right here. You can see the icon right here. It can access to the page right here, and the page right here, it contains all the good features that the machine has. So first thing I want to talk about is the machining data. So machining data, you can get to it by simply press 2 input, or you can go to app 2 right here. So the machining data is something that unique that we just built for the new machine right now. All machine we're using the work coordinate system, and then it's going to be easier with the MC data right here because we control every information we put in here, and the machine will use all the information right here later on in order to make the movement during the program. So it makes everything way easier by setting everything zero at the main cap right here of the main spindle, or in the sub spindle as well. Everything is going to touch up on the Z axis right here and here. Another thing is we can have a setup, quick change, very good for this machine. So basically you have like lots of a program that run like months ago, and then you want to load it back in and then run it again. So all the information when you fill out right here in MC data, when you prove out the machine, this information, it will go together, it will travel with the program. So for the next time, when you load it in, all the information right here will go back into the machine, and then you don't have to worry about anything at all. It will remember all the things on the tool that you used last time. So the next feature that we can have, and again, we're going to go back to the custom page right here. we go call it is the thermal revision. So the thermal revision right here, it allows you to enter the information whether you're going to use the coolant base or you're going to use the oil base. So we have throughout the machine, we have a lot of sensor with thermal sensor. So it gives you the ability to control the machine like grow. So when the machine is heat up or cool down, it will not give you a problem. Another thing is right here, we're going to talk about the tool monitoring. Is one of the most feature that have a lot of good feedback from the customer too. So tool monitoring right here is allows you to set up the monitor, so to record the load that the tool going to apply. So the first thing we can go over right here, we're going to go select and setting right here. This first page right here, it tells you, okay, what level of the load that you want to stop the machine. And then since you run the machine a lot of time, and then you know, okay, maybe this tool, when the load come up to 120%, which is I set right here. So that when the tool is getting wearing out, and then it start getting dull, so it put a lot of load on the tool, it will record it. At the time it reached to 120, it will stop the machine after the cycle right there. So you don't have to worry about getting bad parts and then breaking more tools after that. So another thing right here in this page, with the tool monitoring, it will allow you to record a different axis right here as well. The first axis is going to be X, Z, and Y. And then also with C axis, with you using live tool, it will let you to record the load on the live tool also. And then spindle 1 or spindle 2, whatever the spindle it involves cutting, it will record the loads at well. And then it gives you the ability to record up until 32 tools. So it's a lot of tool right here for you to record and then keep track on it. One thing right here is I want to mention is the offset right here. So with the offset, we can make adjustment with 5 digits after the decimal point. So it's a really accurate machine. So we want to make the adjustment up until micron. So this is how good the machine is performed. Whenever you put 1 micron adjustment, the machine is actually moved 1 micron, exactly what you command. So it's all the good feature that machine has right here. Next thing I want to go over with the program a little bit right here. Since a lot of people see, okay, this machine has a lot of tool, it's really crowded inside right here. As you can see, we have a lot of tool on the turret. We have double holder, we have everything in here. So it's kind of really crowded machine. So a lot of people get scared because how we can control it, how we gonna program it to make sure like nothing like unexpected happen. So I'm gonna tell you, it's very simple on this machine. We have the Cheese 500 code right here. It will tell you, tell the machine exactly what tool we're using and where we're gonna move it, and then it will catch up any interference if it happened during the program moving. So it's really simple to program it, and then basically head 1 right here, we control the main spindle, and then head 2 right here, we control the sub spindle. So sub spindle right here working with the sub turret, the main spindle working with the main turret. And then sometimes we have the G530 mode, which is the synchronized mode. It allows you to use the main turret to work simultaneously for the both spindle. So with the programming and all the code, all the queuing code, it makes everything way easier than you think. So it makes everything is more sense in the way that you control. Okay, if you call the tool, it's going to react right away exactly what tool in what mode that you want to run. So like I said, very simple machine, but it's good performance, easy way to program. heavy machine, handle big cut with a lot of tool ability. We have a lot of holder, variable holder for you to pick up, either one single holder, double holder, triple, whatever you can think of. And then also the same thing too with the live tooling. We can have the live tooling that work for main spindle only, or we can have double live tooling just like this one right here. It can use the live tool to work for the main and the sub as well. So this all information that I gave you for the machine. And next, we're gonna have a video that we already recorded to show the machine performance. So this is the next video we're gonna see.
Take a look now at this part that we're running on the B&J 51 SY6. Note the compact size of the machine, fan and control. Both spindles come into operation and play for simultaneous turning, front and back side. Turning the OD on both spindles. ID work on the front side while we're finished turning on the back side. The live spindles are 6,000 RPM high torque spindles. Do some heavy duty machining this way. Right now we're just chamfering on the front side. What we're going to do is we're going to come simultaneously working front and back using superimposition. To save time, we're drilling through holes on both sides in different positions. Axis superimposition allows the machine to know where its positions are of each spindle relative to the other. Now doing a boring operation in the front side. Backside drilling, utilizing a boring bar here. Thread milling on the backside. As you can see here, C-axis. Front side, we're using a mill interpolation, again using the C-axis. You'll see this right here. Part eject into the parts catcher, standard feature of the machine. Note the unique design of this back turret, allows for clearance, faster tool change times, faster pickoff. Part picks off, spindle sinks. Machine cuts down, ready for pickoff. Cut it off, retracts the part. Okay, I'd like to have Jack McGinnis now come up and say if you show a little more features on the B&J and be available to answer any questions that you may have.
Hi, go ahead.
All right, welcome back everyone. Now I'm going to introduce to you is Jack McGinnis. He's one of our sales right here in California office.
Thank you, Han. Appreciate it. Good job. So just in wrapping up, I did a great job explaining the machine. The Miano machine, Citizen brings this machine in ready to run, ready to go. As Han had indicated, the spindle, very rigid. We've got 2 sets of angular contact bearings in the front and a set of roller bearings in the back. So ready to support up to a 12-foot, 2-inch bar. We can handle that. The machine comes standard with collet noses, both the main and the sub. Cut-off detection, so we know the bar has been, the stock is, the part has been cut off. Parts catcher, parts conveyor, control light, and all the control functions that used to be options years ago are in there now standard. This thing is ready to go out of the box. Again, very heavy, rigid construction. We can take aggressive cuts on this machine and very, very accurately. So with that said, if you have something you'd like for us to look at for you, a part, we're here to help. Yeah, I know it's a very good machine. Out here in the Southern California territory, I've got machines literally that are still running today, go back from 1990, 92, 93. still running every day, many of them. So let us take a look at what you have. We can offer a solution. Thank you. I think now we're going to Glenn.
Jack, we got a couple of questions.
Questions and answers.
Yeah, Richard, you want to field the question?
Can we do thread rolling operations?
Yes, we could put a thread roll in the machine. Certainly we could. We've got all the motions required to thread roll on this machine. Thread mill on this machine, thread roll on this machine, anything you require to that effect.
That's it for questions.
That's it for questions? Okay.
Give it a moment if we get any new questions.
So we're just going to wait 1 second to see if we have any more questions come in. And if there aren't any more, we'll give it another minute. We're going to send this off to Glenn Cruz to wrap up our session today. Thank you. Appreciate your attendance.
All right, thank you, everyone.
That concludes our presentation of the Citizen Miano machines for today and wraps up our 4-day event. To start off, I'd like to just personally thank the staff at the Fountain Valley office for all the work that they did in helping it. Richard and our speakers today, Jack McGinnis, Mike Maldonado, Hom Fan, and Bailey Stump. I'd also like to thank Brian Reel and Matt Stawicki, who did a lot of the work in the setting up the machines in the background, and all the support staff of the Fountain Valley office. I'd also like to thank our dealers who participated by providing some really excellent videos, some really exciting things. The dealers actually are the backbone and the heart of MCC success. We have some of the best dealers. We have the best dealership network of any of the machine tool companies in the United States. They are really directly responsible for how successful we are with their direct support that they do locally. In many cases, our dealers are strictly Citizen and Miano products. That's what they deal with exclusively. In the cases where they don't, they have departments that are dedicated strictly to the Cincom and Miano machines. I'd also like to thank some of the suppliers that helped us out today, and NTK and Mitsubishi Cutting Tools, Platinum for all the tool blocks, and for Esprit programming software for helping us program some of the machines. Now, in wrapping up, I'd also like to just summarize that what we've shown this week on Tuesday, the MCC New England office showed a B&E 51 MSY, a D25, and the L12 with the laser, as well as some of the accessories and special products that they make there. Our Elk Grove office gave you the B&A 42S2 and the L12 Type 10. Our New Jersey office demonstrated the L20 Type 12 with the automatic tool changer, which is really an exciting new technology that nobody else is offering. The X51 MSY you've seen today, the Fountain Valley, the M532 Type 8, the L3210, emphasizing and showing the new LFV function that's available on those machines now, and the B&J 51SY6. Thank you for attending, and you can find out more information or follow us on any of these social media networks. And remember, our website is www.marusit.com. You can go there. There's a wealth of information about the machines and the resources as far as our training classes, schedules, and you can connect with your dealers through that. So again, we'd like to thank you all for coming and enjoying this video and this presentation we've had this week. This is Glenn Cruz signing off from Fountain Valley. Thank you. Bye.